The demand of high-quality differentiated service is growing. And today's session, we are going through an innovative way to address assurance based on an intent-based, top-down, service-centric approach. You will learn through use case how Crosswork Network Controller, we already seen something with Deepak, Hierachical controller and provider connectivity assurance, provide complementary assurance capability aligned to the operational structure operator use to manage SDN domain and monitor network performance. Any operator care about a service level agreement, and that is bread and butter to ensure you can maintain customer base and avoid customer churn. A Forrester research reported that troubleshooting is usually taking 80% of the overall mean time to repair. If we consider the insertion of a new technology, this requires time to adoption from operation. Most of the time, initially, issues are going to be escalated to level 2 and domain SME operator because of the novelties and the different behavior that technology may have. Another Forrester research tells us that 74% of the issues are found by the end user before internal tool are able to identify those issues. The challenge fundamentally is the ability to understand how SLA contract map to the network health itself and assure that the network can maintain the state regardless of anything that happens in the network. Finally, 30% of the issues are usually repetitive issues that affect the overall productivity time. We shall help first and second level to avoid escalation by providing visibility of the health of the infrastructure without going into the detail of the technology. In other words, aligned to the operator task and know-how. The first affect the agility to innovate and onboard new technology. The second affect the customer experience, and the last we say that affect the productivity. So automated assurance take a different approach to assurance that is intent-based or service-centric. We directly track the health of the service through probing that can be internal probing or external probing, leveraging of provider connectivity assurance, because this is the quickest way to answer the question, is my service healthy? We track then the health of those infrastructure component, interface, device, policy that are directly related to the service that is monitored and impacted. We automate the continuous check of those infrastructure components so we can provide an immediate view of the possible symptom and help the operator to improve productivity and reduce the overall mean time to identify and mean time to know. Automated assurance take a multi-layer approach reflecting the operational structure, as I said at the beginning, of the operator used to manage SDN domain and monitor network performance. Reason is that we have different operator with different role and different know-how. Cisco approach is not to replicate same function across the stack, but provide the capability and assurance functionality aligned to the specific task, role and know-how that the operator has. Going through this view, the first level focus on meeting customer service level. This level requires service and SLAs dashboard, so the operator can quickly identify service is assigned to is degrading. The second level use multi-layer topology view to drill down and determine domain source of the cause of a specific service issue and alert the proper domain SME. The domain SME need to actually have a deep visibility in the specific domain that can be IP or optical domain, and will leverage the appropriate domain controller to actually get all the troubleshooting activity. So looking at the provider connectivity portfolio, here are the main players for the automated assurance. We have a provider connectivity assurance that provide proactive service quality analytics and give an unprecedented visibility on the service flow through the network. The Hierachical controller provides a topology-based correlation, helping the operator to understand which is the domain, Cisco or third party, in trouble and which domain SME to activate. And Crosswork Network Controller provides a detailed view of the IP transport domain, connecting service health to the path health to the infrastructure health in a complete multi-vendor environment. With that, I hand off to Chris to speak about the provider connectivity assurance.
Thanks, Paola. Pleasure to be here and speak with you all today. It's been just over 1 year since succeeding to join Cisco, and I'm sure a lot of you have heard of us. I'm going to try to impart 3 takeaways for you today in my short time with you. One, that provider connectivity assurance is an awesome choice to help you assure your critical networks, and that goes beyond just dealing with service providers. We're plugged into all of your favorite Cisco tools to enhance your experience with those tools. And I want to share some exciting new collabs that that are in the works to bring assurance closer, all the assurance stories closer together. An operator cares a lot about, sorry, that's not my slide. I mentioned critical networks, and those aren't necessarily people working from home and accessing traditional online services, although Cisco has solutions for that. We're talking about like remote health services or banking or trading institutions, robot connectivity in automated factories, access to critical applications. There's a reason people pay a premium for high performance networks, and our solution is here to help you know that you're getting what you're paying for. The example here is a traditional technique that would give you the impression that you're meeting your SLA. You have a threshold of 2 milliseconds and you're meeting it. When you leverage high resolution data, you can actually see that that peak is getting averaged out, or you're not finding that peak because you're sampling too infrequently and having less accuracy in the results. So you're really hitting 4 millisecond peak delay, which could have an effect on some critical applications that your customers are running or that you're running. Okay, the brawn of our solution are our sensors. They provide access to continuous ultra granular performance metrics. The platform runs our analytics tool set, and it's the brain. It makes observation and exploration of this data, this rich data set, very easy. It provides a network-wide visualization via a single pane of glass. It has intuitive workflows to help you deep dive and narrow the focus during network performance investigations. It's also capable of pulling in telemetry from other sources to help you provide additional context and drive your analysis and investigations even further within a single tool. It's a big data platform. It uses a lot of statistical methods and machine learning models to uncover anomalies quicker. It's customizable using rollback access control and different other tools. So you can have multiple personas like quality engineers, NOCs, capacity planners, even product managers, having access to the same tool and being able to use it slightly differently. A lot of our customers are even using this to give segmented access to performance data for customers as a customer portal. So instrumentation is kind of key to success because you can't see what you're not measuring. Provider connectivity assurance offers both hardware and software sensors. Hardware sensors come in a variety of form factors like NIS, modules, and SFPs. Our software sensors also come in a variety of form factors like containers and VMs. So we have sensors to fit all kind of use cases. Both have similar goals of either actively or passively monitoring services end-to-end. Active testing obviously involves pushing packets and measuring the one-way or two-way performance. Passive is more analyzing that transactional performance. But the key of having both in one spot is that you can tell where the fault is in the network and the impact to the customers or applications. So this is a very busy slide, but I wanted to share kind of how we fit in the Cisco world. And clearly it's right in the middle because I created this slide. But being an engineer, I'm going to start at the bottom at the data collection layer. Besides pulling our own sensor data into the platform, we also collect third-party telemetry via any modern or not so modern method. We'll touch on our Cisco integrations in a moment. We just released some out-of-the-box XR and XE MDT feeds capability, so you can pull some of those device telemetry into the system as well. And we're collecting segmented routing performance metrics and power metrics. And with our Crosswork integrations, which we'll talk about in a moment, we're doing some pretty cool stuff. On the Crosswork side, they can use our interfaces to automate test creation, and they can react to our results by performing either closed loop actions or updating that higher order service health status. And then we benefit from access to the better metadata on the service and topology. On the top, we recognize that people aren't always staring at one of our dashboards waiting for something to happen, and that's why we have great integrations into customers' ticketing systems or wherever they want those notifications, whether it be WebEx or Slack. And then with Cisco's observability tools, we're obviously working closely with App Dynamics. We launched an integration with them over the summer. We have a Splunk integration that Rockray was talking about. That's coming out in February, and we're actually actively developing an integration with Thousand Eyes right now. Just to touch on the NSO, because this is a Developer Day conference, we'll touch quickly on the NSO integration. We have a network element driver that's available. We have a new one that just came out. It's able to create all the tests on our hardware software sensors. It can provide the metadata in a programmatic way, and it can actually set the thresholds for alert policies. And then we can notify NSO of alerts, and you guys can design closed loop reactions to that. Okay, we're specifically dealing with TWAP for the active testing, which is great for two-way active measurement. And we also do SAT, which is system activation testing. Okay, the last section I'll mention, Paola, I know I'm running long on time, is around our integration with Crosswork. So we have a few really exciting things happening in the integration with Crosswork, with either the HCO or the CNC products. We can adjust their topology data and correlate it with our end-to-end, use that to correlate our end-to-end performance data to the lower layer constructs like segment routing, power efficiency, and optical performance. You've probably seen some of these demos over the past. We're really excited to show you what progress we've made with some key customers very soon. Okay, great. Thank you. I can skip the demo.
Okay, thank you, Chris. So let's go over the rest of the portfolio. So the Hierachical controller provides topology-based correlation, helping the operator to understand which is the domain in trouble and which domain SME to activate. Let me go through some of the functionality, the assurance functionality that the Hierachical controller has. Crosswork Hierachical controller provides end-to-end multi-vendor and multi-layer visualization in a single pane of glass. The Hierachical controller models the connectivity across the different layers and deliver full visibility from the service to the fiber. Thanks to that, the layer service view will provide a visual correlation between the health of each layer and the visual impact. Then we actually have also a root cause analysis application through which we can see the links that are impacted. So in the short demo, we are seeing, the root cause analysis. By selecting the link impacting, I have the information of the health of each layer is provided with each domain controller that the Hierachical controller interact with. Another functionality is the performance application that focus on traffic metric across the different layers. Traffic metric are used by HCO to identify connectivity between the IP and the optical layer. Then we actually have a service and link assurance that provide a view of the service and the link connectivity. In this specific example, we are seeing the link assurance. The link assurance provides the connectivity to the DCO optic with the related status and performance collected as we can see here. The Hierachical controller collects through the domain controller only the operational and relevant metric to understand the health of the topology object that it represents. So in this view, we are seeing the different layers. Let me go on now to the Crosswork Network Controller. The Crosswork Network Controller provides a detailed view of the IP transport domain, connecting service health to the path health to the infrastructure health in a multi-vendor environment. The Crosswork Network Controller delivers assurance capability at each layer that is visible by the SDN IP controller. So let's actually go one by one. So it actually provides infrastructure health by including inventory fault performance and leverage on real-time visibility through introduction of model-driven telemetry. It actually monitors the health of the transport policy using SR performance management, a TWAMP-based tool. We are proactively monitoring VPN services by productizing an IETF RSC 19417 called Service Assurance for Intent-Based Networking Architecture, and we combine it with the data plane verification, leveraging on probing, like both embedded or external probing, leveraging on the provider connectivity assurance sensor. Thanks to all these tools, we can extend also the monitoring to slice health as a combination of the health status of the subtending VPN services. If we look at one by one, right, so by bringing the inventory, fault, and performance, we just want to help the operator clearly define the physical component that may cause of a service degradation. Instead of proceeding bottom up, trying to understand which is the service impacted by a specific failure on a port, we can drill down to the service impacted to the specific physical component detail. We can see all the alarm and event that are on a specific device supporting the impacted service and remove from the operator the noise related to the alarm and other device not supporting the specific degraded services. Telemetry brings a large amount of operational performance data in real time. This enables a near real-time visibility of the network, but the operator will be overwhelmed. Instead of collecting everything, we are actually monitoring only those parameters that are important to understand the health of the status of the infrastructure. And we leave, the analytics to the provider connectivity assurance application. As per the transport level, XR, as I said, introduced instrumentation to enable to measure traffic engineer policy, SR traffic engineer, both for SR traffic engineer and SVP traffic engineer, and IP endpoint delay and loss. SR is based on a TWAMP light standard. It has been validated by ENTC testing to work with other vendor, and why we needed to be initiated by the XR device can interact with any responder. In Crosswork, we are currently using SRPM for link health monitoring. This is because majority of the issues of the service can be reconducted to degradation of the link. So monitoring the link is a key to understand the infrastructure health. And we are using that for also monitoring the health of the policy and for IGP metric. SRPM is used also to enable real-time optimization or latency utilization change with respect to the intent. Of course, we actually expose all the results so that can be consumed by the customer ecosystem. Service health is the productization of, as I said, of the service assurance for intent-based networking, RFC 9417. Service health combines the health of each layer with the result of the empirical testing of the service through probing, providing a service-centric view of the service monitored. Given the goal is to expose insight in a way that is consumable by the user, Service Health provides through the assurance graph a way to quickly identify the possible reason of degradation of a service, helping the operator simplify the troubleshooting. Moreover, Service Health provides a timeline view, so the operator can understand if the issue that is seeing on a service right now it has also been present in the past. Current version of the Crosswork Network Controller is integrated also with the provider connectivity assurance and to enable end-to-end monitoring of layer 2 VPN leveraging on TWAMP session. And we are leveraging on provider connectivity assurance because not all the third-party applications are actually supporting the same level of probing. How this is done in two steps. The first step is like the layer 3 service definition that we actually have in NSO. The intent is extended to include also the TWAMP session with the desired topology, full mesh, hub and spoke, or specific endpoint. When user initiates the monitoring automatically, the controller will request the initiation of the session in the desired topology to provide connectivity assurance. Additionally, service information are added to the request as metadata and then Crosswork Network Controller will subscribe to the GNMI path generated by provide connectivity assurance and combine this information in a single view. But let me show you how it happens through a short demo. So here we are seeing that there are 9 services, out of which only 6 are actually the ones that are monitored. If I click on the one that are degrading, I will see only the services that are actually current in a degraded view. I remove, the filtering, and I can see also the one that are not monitoring. To enable the monitoring, start with a simple click. The user will just select which is like the configuration, what Sujay was actually showing before. And based on that configuration, the system will initiate all the assurance parameters that need to be initiated. So the operator is actually shown only with a few information. It needs to know that it's degraded, which is the policy that has been defined. And in this specific example, also the system actually have automatically initiated 3 different sessions with leveraging the integration with PCA and getting the information from PCA. So at each time I can know which one of the session is actually causing a degradation. If I look at the overall view, and I actually have a single view, I can actually drill down and see simply which are actually the component of the service that are actually monitoring independently and are causing degradation of the service. As we say, we can actually go back, see which is like the reason of the symptom, and actually have some hint of this information. Let me go a bit quicker. Okay, so we actually have also the historical view, and every time there is a degradation, the system will keep an history of 12 hours or 24 hours of the status of the metric collected, in order actually always to help in the troubleshooting. And here the information that you see are again coming from provider connectivity assurance. So here a short summary of how the approach of automated assurance can address the operator challenge that we have seen at the beginning. The first level and customer can have a quick view of the SLA status, customer specific on his service and the front line across all the service. The second level can quickly identify through an end-to-end topology view, which is the domain SME that need to be alerted. And they will also have a quick view of the health of the service and possible degradation reason through both PCA and Crosswork Network Controller. The domain SME can focus on innovation and automated troubleshooting step to reduce the overall mean time to identify and mean time to know, as we have seen during the session from Neil, Deepak, and Sujay. And with that, back to you, Omar.
Thank you, guys. So quick question. We saw a lot of cool screens. I know both within our tooling, also within PCA for dashboards and those kinds of things. But what if I want to, like Roque session, what if I just want to deal with the raw data and pull it into other tools? Do I have access to all this assurance information kind of in its raw form that I can go play with in something else?
To you, Chris?
Yeah, that's a great question. So we try to abstract a lot of the insights via alerts and aggregated metrics, because we are doing high frequency sampling. So we have a lot of data. It's probably not ideal for people to try to manage to do all that with the raw data, but rather to use our insights to drive those upstream operations and correlations.
So yeah, sorry, but I should have been more clear. Not the raw data itself, but your insights, your alerts, those kinds of things are available
exactly. So we have
stream.
Exactly. We have an event stream which we can use to integrate into customers' existing solutions, whether they want to raise tickets or get a Slack notification or WebEx notification, or whether they want to send that up to Splunk, which is what Roque was talking about.
Mm-hmm.
And then we also have like App Dynamics. We have an integration with them, and Thousand Eyes integration is coming soon.
Cool. And Chris, like, since we're chatting, another quick question for you. So just looking at your slide with PCA in the middle, it seems like there's a lot of opportunity for that to be able to pull in a lot of different signals, not just the traditional networking ones, or the ones that we tend to talk about. If it can be a little bit more of a big data platform that you can use as an aggregation point for lots of stuff.
Yeah, exactly. We are performance specialists. We've been doing it for a very long time. Our platform is specifically developed for time series analysis. So that's most of our tooling is built around, troubleshooting in any time series. It doesn't have to be network performance information necessarily.
Okay, cool. And Paola, what do you find is the place customers start with assurance? Are they starting with kind of with network assurance? Look more for service assurance? What's the low hanging?
Traditionally, they have started with a bottom-up approach, right? So starting from the network, try to understand which service is impacting based on the failure that I actually have on the network. And that is like where we are suggesting a different approach, right? Focus on the service, because that is like the important part, right? And once you actually have seen the degradation of the service, we can help you in identify quickly which are the components in the network that actually are causing the degradation of the service.
And when we're talking network here, we're talking IP network, optical network, both networks.
We are speaking about IP network when we are speaking about the Crosswork Network Controller, but we can provide end-to-end visibility across IP and optical network, leveraging on the Hierachical controller.